Light has only one speed, not a top speed it works its way up to, not an average with faster and slower examples scattered around it. One speed, held to exactly by every particle of light that has ever existed. The photon leaving the candle on your table is moving at precisely the same speed as a photon from a gamma-ray burst at the edge of the universe, an explosion so violent that a single one of its photons could tear through solid metal. Two fires that share nothing, and the light they make comes out identical in the one respect you would swear the fire controlled. Nothing pushes these photons. Nothing speeds them up. They are never slow, never fast. Only this single speed, from the first instant they exist. And that raises a question almost no one stops to ask. Why doesn't light ever accelerate? Why is there no moment when it starts slow and builds up to that speed, the way everything else in the universe does? Get comfortable and hit subscribe if you're new here, because by the end of tonight, you will understand why light never had to reach its speed at all, and the answer is stranger than the question. Now, let's slowly ease into this. Part 1. The Three Fires. Somewhere in a quiet kitchen tonight, a candle is burning, and it is throwing light onto the walls without any effort at all. That light feels like the most ordinary thing in the world. You have watched it 1,000 times, and you have never once stopped to ask it a single question. And yet the light leaving that small flame is doing something so strange that, once you finally notice it, the strangeness never quite lets you go. Let me put three fires beside each other in your mind. The first is that candle, burning through a chemical reaction at a temperature of perhaps 1,500 degrees, warm enough to read by and gentle enough to sit beside. The second is a quasar, the blazing core of a galaxy at the edge of the observable universe, pouring out more light than 100 ordinary galaxies combined, powered by matter falling toward a black hole 1 billion times the mass of the Sun. The third is a gamma-ray burst, the final scream of a collapsing star, an event that releases more energy in a few seconds than the Sun will radiate in its entire 10 billion-year lifetime. Three fires. One small and calm, one enormous and steady, one violent beyond anything words can hold. Now watch what leaves them. The candle emits light. The quasar emits light. The gamma-ray burst emits light. Every one of these fires produces photons, and here is the thing that should stop you. The photon that just left your candle is moving at exactly the same speed as the photon that has been racing across the cosmos for 13 billion years. Not close to the same speed, not roughly the same, exactly the same, to as many decimal places as any instrument has ever been able to check. There are no fast photons. There are no slow photons. There are only photons, moving. I want you to sit inside that fact for a moment, because it is easy to nod at and walk past, and it deserves better than that. Picture the instant of birth for each of these three photons. In the still kitchen, at the very tip of the candle flame, a molecule releases a small packet of light, and that packet is already traveling at full speed the moment it exists. Far out at the edge of everything, in the searing atmosphere of the quasar, another packet of light is flung loose, and it too is already at full speed, instantly, with no wind-up and no delay. And in the collapse of the dying star, in a furnace so hot and so violent that our best physics can barely describe it, a third packet of light is born, carrying an almost unimaginable amount of energy, and it also, from its first instant, is moving at precisely the speed of the other two. No countdown, no ramp, no fastest, no slowest. Three births in three fires that share nothing at all, and the one thing they produce comes out identical in the single respect you would least expect. This is not how anything else in the world behaves. Think about how ordinary motion works. Throw a baseball gently, and it drifts across the yard. Throw it as hard as you can, and it snaps toward the fence. Fire a bullet from a small pistol, and then from a heavy rifle, and the two bullets leave at very different speeds. Push a car from a standstill, and it gathers pace slowly as the engine works. In the ordinary world, the speed of a moving thing is a downstream fact about how it was launched. Different launches give different speeds. That is the rule almost everywhere you look. A stronger push makes a faster thing. Light simply does not obey that rule. The source of a photon decides a great deal about that photon, as we will see in a moment, but it does not decide its speed. You can make the fire hotter, more violent, more energetic, by any factor you like, and the light that comes out will not move one fraction faster. You can make the fire so gentle it barely glows, and the light will not come out one fraction slower. The candle's light and the gamma-ray burst's light are, in this one respect, the same light, moving at the same speed through the same empty space. And the question that opens up underneath all of this, the question we are going to follow tonight all the way to its end, is simply this: why? Why does light have only one speed? What decides that this specific speed, and no other, is the speed that every photon in existence is required to obey? Where does that speed even come from, if not from the fire that made it? Hold on to the question, because the honest answer is stranger than the question itself, and we are going to earn it slowly. Notice, first, that the strangeness is not really about how fast light is. We tend to think of the speed of light as impressive, because it is large, because a beam of light could circle the Earth 7.5 times in a single second. But the largeness of the number is not the mystery. A rifle bullet is fast too, and we do not find it mysterious. What is mysterious about light is not that it is fast, it is that it is always exactly the same. The speed is not a range, it is not an average, it is not a typical value with fast and slow examples scattered around it. It is one value, held to with a precision that no other quantity in nature seems to demand. You can feel how unusual that is by trying to think of anything else that behaves this way. Sound does not. Sound moves faster on a hot day than a cold one, faster through water than through air, faster through steel than through water. Its speed depends on what it is moving through and on the conditions. Waves on the ocean do not all move at one speed. Cars, rivers, wind, thrown stones, falling rain, none of them hold to a single fixed speed the way light does. And yet light, produced by chemical flames and nuclear furnaces and quantum jumps inside single atoms, produced by processes that have nothing whatsoever in common, comes out at one speed every single time, everywhere in the universe, with no exceptions that anyone has ever found. There is something almost unsettling in that once you let yourself see it. The universe seems to have decided, at some level far below the fires and the atoms, that light gets one speed, and that the choice is not up for negotiation, not by any star, any explosion, any laboratory, or any hand. So this is where we begin, not with an answer, but with a fire, and a photon leaving it, already at full speed, the way every photon that has ever existed has left every fire that has ever burned, and with a quiet, patient question about why that should be so, a question that is going to take us through the work of a self-taught bookbinder in a London basement, through the most famous failed experiment in the history of science, and eventually all the way down into the shape of space and time themselves. But before we can go anywhere near an answer, we have to understand the mystery properly, and that means understanding exactly what a fire does control about the light it makes. Because the source controls almost everything about a photon. It controls nearly every property light can have. There is only one property it cannot touch, and that single exception is the whole story. Part 2. Everything the source controls. Let me be fair to the fire, because it would be easy to think the source of a photon is helpless, and nothing could be further from the truth. When a candle, a lamp, a laser, or a star makes light, that act of creation fixes a whole set of the photon's features. The source is powerful. It shapes almost everything about the light it releases. To feel how strange the speed really is, you first have to see just how much the source does control, so that the one thing it cannot control stands out against all the rest. Start with energy. Every photon carries a specific amount of energy, and that amount is decided entirely by how the photon was made. Inside a single atom, when an electron drops from a higher rung to a lower rung, it releases a photon whose energy is exactly the gap between those two rungs. Whatever that gap happens to be, that is what the photon carries away. A different atom, a different jump, a different amount of energy. A microwave oven makes photons of very low energy, because the process that generates them nudges the electric field back and forth slowly, producing light with wavelengths of a few centimeters. A medical X-ray machine makes photons of enormous energy, because it slams fast-moving electrons into a metal plate, producing light with wavelengths thousands of times smaller than an atom is wide. The source decides the energy, and it can choose from an almost limitless menu. Tied tightly to energy is frequency, which is just how many times the light wave oscillates every second. There is a clean relationship between the two, one of the most reliable equations in all of physics, written down by Max Planck in the year 1900 and extended by Albert Einstein 5 years later. The energy of a photon equals a fixed number, Planck's constant, multiplied by its frequency. This means that once the source has set the energy, it has automatically set the frequency as well. High-energy photons oscillate at dizzying rates. A gamma-ray photon might complete 100 billion cycles every second. A radio photon might complete only a few thousand. And because frequency and wavelength are locked together by the speed of the wave, setting the frequency also sets the wavelength, which is simply how far the light travels in a single oscillation. So the source, in one stroke, fixes energy, frequency, and wavelength, all three bundled together, and it can place them anywhere across a span of more than 20 factors of 10. That is a range of energies so wide that if you compared the weakest photon to the strongest, as though they were animals, you would be comparing something smaller than a virus to something larger than a whale. The source controls direction too. Point a laser to the east, and the light comes out heading east. Let a bare bulb glow, and the light pours out in every direction at once. For a single atom, there is some quantum randomness in which way a photon flies, but even then, the atom's surroundings and orientation set the odds. And once the photon is out and moving through empty space, its direction is fixed until something gets in the way. The source aims the light, and the source shapes polarization, the orientation of the wave's electric and magnetic parts as it travels. Some sources make polarized light naturally. Sunlight bouncing off water becomes partly polarized. Laser light comes out strongly polarized because of the way it is generated. The scattered light of a fluorescent tube is mostly unpolarized, because the many atoms inside it emit without coordinating with one another. However the light is made, the making of it stamps in the polarization. So look at everything the source holds in its hands: energy, frequency, wavelength, direction, polarization. That is a rich and complete set. In fact, it is very nearly the entire list of properties a physicist would ever think to specify about a wave. If you handed a physicist those 5 numbers, they could tell you almost everything there is to know about a given beam of light. The source is not helpless at all. The source is nearly a god over the light it makes. And still, after all of that, the source does not control the one thing we started with. It does not control the speed. That speed is fixed. It is fixed for every photon that has ever existed and every photon that ever will. You may set the energy anywhere across 100 billion-fold range. You may aim the light any direction, tune it to any frequency, twist it to any polarization. The speed does not move. It sits exactly where it always sits, the same for the candle, and the same for the collapsing star. I want to let that contrast land, because it is the heart of the mystery, and it carries a strange kind of weight. Take two photons, one from the flame of a candle, and one from a gamma-ray burst. Ask a physicist to compare them, and they could talk for an hour. The two differ in energy by a factor of trillions. They differ in wavelength, in frequency, in how far they can pass through solid matter, in whether they would warm your skin or pass clean through your body, in what they would do to a living cell. By almost every measure you could name, these two photons could hardly be more different. And then you ask the one last question: how fast is each of them moving through empty space? And every difference between them, every single one, vanishes. The answer is the same, exactly the same, down to every decimal anyone has ever measured. Speed is where the differences disappear. Think about how odd that is. Of all the properties light can have, the universe has chosen the one we might have guessed would depend most on the violence or gentleness of the fire, and made it the one property that is completely deaf to the fire. A candle and an exploding star agree on nothing about their light, except the single thing you would have bet the fire controlled. It is as if nature took the loudest, most obvious feature of motion and quietly declared it off limits, the same for everyone, no matter what. So here is how I want to sharpen our question. It is not enough to ask why light is fast. We have to ask something more precise and more troubling. The source of a photon imprints everything about that photon, except its speed. Speed is not the source's to give. So if the fire does not decide the speed of its own light, then what does? Something is fixing that speed, holding every photon in the universe to one value, and whatever it is, it lives outside the fire, outside the atom, outside the source entirely. We do not yet know what it is, but we have at least learned where it is not. It is not in the flame. And that already rules out the first thing almost everyone reaches for, which is the natural, obvious, entirely reasonable guess that a more powerful source, a more energetic photon, ought to be a faster one. It is such a sensible thought. It is also completely wrong, and the universe itself has run the experiment to prove it, on a scale no laboratory could ever match. Part 3. The photon that should have been faster. Here is the intuition, and I want to give it its full due before we take it apart, because it is a good intuition. It has served you well your entire life. The thought is simply this: a photon with more energy should move faster. It feels almost self-evident. A gamma-ray photon carries trillions of times more energy than a radio photon. Surely, if you hand nature a more energetic thing, nature should also move that thing more quickly. Everything else in your experience works that way. Every massive object you have ever encountered obeys this rule. Give a car more fuel and let the engine burn harder, and it goes faster. Give a rocket more thrust, and it accelerates. Give a runner more energy, and they can sprint instead of jog. More energy, more speed. It is one of the most dependable patterns in ordinary life. So why on earth would a high-energy photon not simply be a faster photon? Why would pouring more energy into light not make the light move quicker, the way pouring more energy into anything else does? The answer is that photons do not spend their energy on speed. They spend it somewhere else entirely. When you give a photon more energy, that energy goes into raising its frequency, into shifting its color in the broadest sense of that word, into moving it along the spectrum, from radio, toward visible, toward X-ray, toward gamma. The energy decides what kind of interactions the photon can have with matter, whether it can knock an electron loose from an atom, whether it will pass harmlessly through your hand or damage the cells inside it, whether your eye can see it or your skin can feel it as warmth. Energy buys a photon all of those things. It does not buy speed. For light, energy, and speed are simply disconnected, decoupled, in a way they are not decoupled for anything else in the universe. The energy climbs and climbs across 20 factors of 10, and the speed does not so much as flinch. Now, You would be right to want proof of this, rather than a promise. It is a bold claim that a photon carrying trillions of times more energy moves not one hair faster than a feeble one. And the beautiful thing is that we do not have to take it on faith, because nature has set up the experiment for us, out in the sky, on a scale so enormous that even the tiniest cheating would be caught. Here is the reasoning. Imagine that higher energy photons really did travel just slightly faster than lower energy ones, even by an amount so small that no laboratory on Earth could ever measure it, say 1 part in a trillion. Over a short distance, that difference would be hopeless to detect. But now let the photons travel not across a room, not across a country, but across the universe, for billions of years. A difference of 1 part in a trillion, multiplied by billions of years of travel, would slowly accumulate. The faster photons would pull ahead, a little more with every passing year, until by the time the light reached us, the high-energy photons would arrive noticeably before the low-energy ones, even though they had all left their source at the very same instant. So astronomers went looking for exactly that. They watched some of the most violent events in the cosmos, distant supernovae, quasars, and gamma-ray bursts, some of them billions of light-years away. These events flare out light across an enormous range of energies, all at once, in the same flash, from the same place, at the same time. If energy affected speed at all, the different energies would drift apart over the long journey, and arrive at different moments. And so the astronomers compared the arrival times of the highest energy photons, some of them carrying trillions of times the energy of ordinary light, against the arrival times of much gentler photons from the very same event. They found no difference. In one landmark case, in the year 2009, a burst of gamma rays reached us after traveling for something like 7 billion years, and photons that differed in energy by a factor of 1,000,000 arrived within a fraction of a second of one another. After 7 billion years of racing side by side, across a distance the mind cannot truly hold, the energetic photons and the mild ones crossed the finish line together. Whatever tiny head start the high-energy light might have had, if energy affected speed at all, it would have shown up in that 7 billion year journey. It did not. The light arrived together because it had traveled together at one single speed the whole way. And that single case is not alone. Astronomers have run this same check on event after event, on light from sources scattered across the sky and across cosmic history, comparing the arrival times of photons separated by enormous gaps in energy. The precision has climbed with every attempt. In the laboratory, physicists have measured the speed of light in different directions and at different times of year, hunting for even the faintest variation, and pinned any possible change to less than 1 part in 1,000,000, billion, billion. Out in space, the highest energy photons ever caught from distant explosions have been timed against gentler light from the same blasts, and the agreement holds to a precision that reaches down toward the smallest scales physics can currently imagine. Every test points the same way. There is no energy at which light speeds up, no color that runs ahead, no frequency that lags behind. The speed sits perfectly still, while everything else about the light is free to change. And there is something worth pausing on in that, something that should tug at your sense of how the world works. We are used to thinking that if you push harder on a thing, it responds. Pour in more energy and expect more of something, more speed, more motion, more reach. Light quietly refuses the whole bargain. You can hand it the energy of a collapsing star, packed into a single photon, and it will carry that energy faithfully, and do absolutely nothing faster with it. The most violent event in the sky, and the softest glow in your kitchen, produce light that moves in identical lockstep. Somewhere below the level of fires and furnaces, the universe has set a rule that does not care how hard you push, and light obeys it without exception, without effort, and without ever once being asked. This is one of those results that quietly rearranges how you see things. Your intuition, the perfectly reasonable idea that more energy means more speed, has just been tested against a laboratory the size of the observable universe, with a stopwatch running for billions of years, and it has failed completely. Not narrowly, not with some small correction needed. It failed as thoroughly as an idea can fail. Energy, which controls almost everything about a photon, has nothing whatsoever to say about how fast that photon moves. And notice what this does to our central question. We already knew the source could not set the speed. Now we know that energy cannot set it either, and energy was the most promising suspect, the one property that seemed most likely to translate into velocity. We have taken the obvious answer and watched the sky itself throw it out. Whatever fixes the speed of light, it is not the energy of the light. Two photons with energies separated by a factor of 1,000,000 move in perfect lockstep across 7 billion years. Speed is not something a photon earns by being powerful. So one intuition is gone, but there is a second one hiding right behind it, just as natural, just as firmly built into the way we picture the world, and just as wrong. It is the quiet assumption that light, like everything else that moves, must start out slow and speed up, that there must be some first instant when the photon exists but has not yet reached its full velocity, some brief moment of acceleration before it settles into that famous speed. It is such an ordinary assumption that most people never even notice they are making it. And when you look at it directly, it turns out to be not just wrong, but wrong in a way that starts to hint at where the real answer is hiding. Part 4. The speed that was never slow. Watch a bullet leave a gun, at least in your imagination, slowed down until you can see every stage. The bullet begins at rest inside the barrel. The powder ignites behind it. The expanding gas shoves it forward, and it accelerates down the length of the barrel, gaining speed with every centimeter, until it leaves the muzzle at its full velocity and flies. There is a beginning, a middle, and an end to that motion. Rest, then acceleration, then final speed. A ball dropped from a rooftop does the same thing in a different key. It starts at rest in your hand, and once you let go, gravity pulls it faster and faster as it falls, its speed climbing steadily the whole way down. Almost every moving thing you have ever watched follows this pattern. There is a state of rest or of slow motion, and then a push, and then a gradual building of speed toward whatever the final velocity turns out to be. It is so universal that we import it without thinking into our picture of light. We imagine, somewhere in the back of the mind, that a photon must work the same way. First the photon exists, sitting there. Then some process shoves it. Then it speeds up. And eventually, it reaches that enormous velocity we always measure, and off it goes across the room or across the galaxy. That picture is wrong from the very first instant. A photon is never at rest, not once, not for the briefest sliver of time that could ever be named. There is no stage of a photon's life during which it exists, but sits still. The instant a photon comes into being, the instant an electron drops between two energy levels, the instant a nuclear reaction completes, the instant a particle and its antiparticle meet and annihilate, the photon is already moving at the full speed of light. There is no wind-up, there is no acceleration, there is no transitional moment when it is going half speed, or a tenth of the speed, or a hair below the full value. It goes from nothing to full speed in no time at all, because there is no zero state to accelerate away from. Let that phrase sit with you, because it is going to matter enormously later. There is no zero state to accelerate away from. A bullet can accelerate because there is a bullet at rest for it to leave behind. A falling ball can speed up because there is a ball held still to begin from. But there is no such thing as a photon at rest, waiting to be pushed. The photon does not exist first and then start moving. Its existence and its motion are the same event. To be a photon is already to be moving at the speed of light. The two cannot be separated, not even in principle, not even for an instant. I want to be careful here, because this is one of the places where the mystery stops being a curiosity and becomes something you can feel. Think about what it would mean to see a photon at rest. It would mean finding some vantage point, some way of moving, some frame of reference, from which the light was standing still in front of you. You would have to catch up to it. You would have to run alongside the beam, matching its speed exactly, until it hung there motionless beside you, like a car keeping pace on the highway. And here is the quiet, vertiginous truth. There is no such vantage point. There is no perspective, anywhere in the entire universe, from any observer moving in any way, from which a photon is ever at rest. You cannot chase light down. You cannot pull up beside it. You cannot slow it, in your own view, by even the smallest amount by running after it. In every frame of reference, from every possible way of moving, light moves at the same speed. It is never, from anyone's point of view, standing still. Sit with that for a moment before we go on, because it is genuinely one of the strangest facts human beings have ever established about the world. Everything else you have ever known has a version of itself at rest. A mountain, a planet, a speck of dust, an electron in a trap, a ball of gas drifting through space. Every one of them can, from some point of view, be sitting still. You can always, at least in imagination, find the frame in which a thing is not moving. But not light. Light has no still version of itself. There is no place to stand from which it stops. Something exists in this universe that is pure motion, with no rest behind it and no rest ahead of it. A kind of being for which stillness is simply not on the menu, anywhere, ever. And this is not a poetic flourish. It is a hard, measured, experimentally confirmed fact, and it is closely tied to the question we are chasing. Because if a photon has no state of rest, then the whole ordinary picture of motion falls apart for light. The ordinary picture needs a beginning at rest, a push, and a build-up of speed. Light offers none of these. It skips straight to full speed, or rather, it never was anywhere else. 0 to the speed of light in 0 time, forever, for every photon that has ever existed. So notice where we now stand with our question. We asked what sets the speed of light, and we have learned 3 things about the answer by learning what it is not. The source does not set it, because the candle and the collapsing star produce identical speeds. The energy does not set it, because photons are 1,000,000 times apart in energy race across 7 billion years in perfect step. And the speed is not something light builds up to, because light is never slow to begin with, never at rest, never accelerating. The photon does not start somewhere and reach the speed of light. It is born there. That is a strange kind of progress. We are learning the shape of the answer by removing every familiar thing it could have been, and each removal points in the same direction, away from the light itself, away from the fire and the energy and the motion, towards something underneath all of them, something that fixes the speed before the photon is even made. But before we can look at what that something is, we have to deal with one more thing that has been quietly misleading us this whole time. It is the number itself. That famous, specific-looking figure for the speed of light. Because that number, it turns out, is not quite the solid, universe-given fact it appears to be, and seeing through it is the next step toward the truth. Part 5. The number that fooled everyone. There is a number attached to the speed of light, and you have probably seen it. 299,792,458 meters per second, or, rounded off the way most people remember it, about 300,000 kilometers per second. It is a very specific-looking number. It looks deliberate. It looks like nature sat down at the beginning of time, chose a value, and stamped it into every photon that would ever exist. And because it looks so exact and so particular, it is tempting to think that this number itself is the essential fact. That somewhere in the foundations of reality there is a dial set to precisely this figure. But that is not what is happening, and seeing why is the next quiet step toward the truth. The number depends entirely on the units we happen to use. It depends on what we mean by a meter and what we mean by a second, and both of those are human inventions, chosen for human convenience, with no special standing in the universe at all. Think about what a meter actually is today. Since the year 1983, the meter has not been defined by a metal bar in a vault, or by the size of the Earth. It has been defined, by international agreement, in terms of the speed of light itself. A meter is now officially the distance that light travels in vacuum, in one part, in 299,792,458 of a second. Read that again, and you will notice something almost circular. The number we quote for the speed of light is no longer something we go out and measure. It is something we have chosen and fixed by definition, and then we build the meter around it. The famous figure is not a discovery anymore. It is a convention. We decided the number, and then we defined our ruler to make it true. We chose that particular value for a very human reason. It matched, as closely as our best measurements could manage, the older definitions of the meter that people had used for a couple of centuries, first as a fraction of the distance from the Earth's pole to its equator, then as the length of a specific bar of platinum and iridium kept in France, and later as a certain number of wavelengths of a particular color of light. When our measurements of the speed of light became precise enough, physicists realized it was cleaner to turn the whole thing around. Instead of measuring light in terms of the meter, they would fix the speed of light by decree and let the meter be defined in terms of it. The universe was not consulted. The universe has no opinion about the meter, and no idea what a second is. These are our conventions, and the number that falls out of them is ours as well. To see how little the number itself means, imagine choosing different units. If you measured distance in miles instead of meters, the speed of light would come out around 186,000 miles per second, a completely different number describing exactly the same physical reality. And if you chose your units more cleverly still, measuring distance in light years and time in years, then the speed of light would be exactly one light year per year. Not a huge number, not a small one, just one. In those units, light does not race at all. It simply moves 1 unit of distance in 1 unit of time, which is another way of saying it moves at the natural pace the universe allows, no more and no less. Physicists who work on relativity and the physics of the very small do exactly this all the time. They choose units in which the speed of light equals 1, because it strips away the distracting human baggage and makes the underlying structure visible. In those units, the speed of light stops looking like a big, impressive velocity and starts looking like what it really is, a conversion factor, a fixed exchange rate between distance and time built into the fabric of reality. The number 300,000 kilometers per second is not the universe emphasizing something. It is just the size of our second and the size of our meter showing through. Physicists who work this way notice something else fall out, and it is quietly profound. When you set the speed of light to 1, the most famous equation in all of physics, the one relating energy and mass, stops carrying that giant number. It becomes simply that energy equals mass, not mass multiplied by an enormous factor, just mass, because the enormous factor was only ever the speed of light, dressed in our clumsy human units. The equation was trying to tell us all along that mass and energy are the same kind of thing, and the only reason they looked so different, the only reason a tiny bit of mass corresponds to a titanic amount of energy, is that we measure length and time in units that make the speed of light a huge number. Strip that away, choose units the universe might actually recognize, and the disguise falls off. What this tells us is that the speed of light is not really the star of these equations at all. It is the exchange rate that lets us translate between quantities we had wrongly thought were separate, between space and time, between mass and energy. It is a conversion factor sitting at the hinge of reality, and its apparent bigness is an artifact of us, not a feature of it. So when we finally ask where light gets its speed, we should not be fooled into hunting for whatever makes light so tremendously fast. There is nothing tremendous to explain. In the universe's own units, light is not fast at all. It simply moves 1 unit of space for 1 unit of time, at the natural pace built into the geometry, and it is our meters and seconds, not light, that make the number look enormous. So we can set the number itself aside now, gently, as a kind of decoy. The mystery of the speed of light was never really about the digits. Change your units and the digits change, while the physics stays exactly the same. What does not change, what no choice of units can touch, is the thing we have been circling this whole time. Light moves at a specific speed. That speed is the same for every photon, everywhere, always. And that sameness, that invariance, is the real fact, sitting underneath whatever number we happen to paint on top of it. The digits are ours. The sameness is the universe's. Which brings the question back, sharper than before. We have stripped away the fire, stripped away the energy, stripped away the idea of light building up to speed, and now stripped away the very number that made the speed look like an arbitrary choice. Underneath all of it, there is still this bare, stubborn fact. One speed, held to by everything, everywhere. Something is enforcing that. And now, at last, we are ready to go looking for what? The natural first move, the move nearly everyone makes, is to hunt for a mechanism. To look for something doing the work. Some force, some substance, some hand pushing the light along and holding it to its pace. It is the obvious next step, and it leads directly into the most instructive wrong turn in the history of physics. Part 6. Reaching for something to push it. When you learn that light always moves at one fixed speed, the instinct that follows is almost irresistible. Surely something must be doing that. Surely there is a mechanism, a cause, some physical thing responsible for keeping every photon in the universe locked to the same pace. Speeds do not just enforce themselves. Something must be pushing the light, or carrying it, or limiting it. That instinct feels like plain common sense. And every version of it, as we are about to see, turns out to be wrong. The instinct itself is the thing that has to be given up. Consider the first guess. Perhaps empty space is somehow pushing light along at a fixed rate, propelling every photon forward, like a current carrying a leaf. It is a comfortable picture, but it does not survive a second look. Empty space exerts no force on a photon. Nothing is shoving the light. A photon crossing the void is not being carried by anything, not being driven, not being propelled. There is no engine anywhere, not inside the photon and not in the space around it. So the pushing picture fails immediately. Whatever holds light to its speed, it is not a push. Consider the second guess, more sophisticated than the first. Perhaps space is a kind of medium, a substance that light waves ripple through, and the properties of that substance set the maximum speed at which any ripple can travel, the way the properties of water set the speed of ocean waves, and the properties of air set the speed of sound. This is a genuinely good idea. It is the way every other wave anyone had ever met actually works. Sound is a wave in air. Ocean swells are waves in water. A vibration runs along a rope because the rope is there to carry it. Every wave in ordinary experience is a wave in something, a disturbance traveling through a physical medium. So when physicists in the 1800s became convinced that light was a wave, it seemed not just reasonable, but obvious that light too must be a wave in something. And they gave that something a name. They called it the luminiferous ether, an invisible, weightless, all-pervading substance that filled the entire universe and gave light waves a medium to travel through. For decades, the ether was simply assumed. Nobody could picture a wave without something to do the waving, so the ether had to be there. And it made a very specific, very testable prediction. If light is a wave in the ether, then the ether defines a special frame of reference, a state of true rest, the stillness of the medium itself. And that means your speed through the ether should matter. If you moved through the ether in the same direction as a beam of light, you ought to be able to catch up to it a little, and measure the light going slightly slower. If you moved against the beam, you ought to meet it a little faster. The Earth, hurtling around the Sun at some 30 kilometers per second, must be moving through this ether, and that motion should leave a fingerprint on the measured speed of light, depending on which way the light was traveling relative to the Earth's path. This was a prediction you could check, and in the year 1887, 2 Americans set out to check it with an instrument of extraordinary delicacy. Picture the scene. In a laboratory in Cleveland, Albert Michelson and Edward Morley have built an apparatus so sensitive to vibration that they have floated the entire thing on a pool of liquid mercury, a heavy stone slab riding on the metal, so that the whole instrument can be turned smoothly and silently to face any direction. A single beam of light enters the device and strikes a half-silvered mirror, which splits it into 2 beams that shoot off at right angles to each other, down 2 arms of equal length. Each beam races to a mirror at the far end of its arm, bounces back, and returns to the center, where the 2 beams are recombined. When they merge, they produce a pattern of light and dark bands, an interference pattern, and the exact position of those bands depends with exquisite sensitivity on any difference in the time the 2 beams took to make their round trips. If the Earth is moving through an ether, the beam traveling along the direction of that motion should take a measurably different time than the beam traveling across it. And as the whole apparatus is slowly rotated, that difference should shift the bands in a predictable, rhythmic way. Michelson had already worked out how big the shift should be. It should have been about 4/10 of the width of one band. Small, but well within the reach of his instrument, which could see shifts far tinier than that. He and Morley took their measurements with enormous care. They rotated the apparatus through every orientation. They repeated the whole experiment at different times of day and at different seasons, when the Earth was moving in different directions through space. They looked and looked for the shift that would reveal the planet's motion through the ether. They found nothing, not a small effect that needed correcting, not a reduced version of the expected shift. They found essentially nothing at all. The tiny variations that remained were no larger than the natural noise of the instrument. The predicted shift, the one that should have been 40 times bigger than the smallest thing they could detect, simply was not there. The most careful search anyone had ever mounted for the medium that carried light came back completely empty. It was one of the most important failures in the history of science, and its meaning was hard to accept. The harder they looked, the more emphatically the universe answered that there was nothing there to find. Physicists spent years trying to rescue the ether, proposing that the Earth dragged it along, or that objects moving through it mysteriously shrank by just the right amount to hide the effect. But the rescues grew more strained and more artificial, and one by one they failed, and the plain reading of the experiment would not go away. There was no ether. There was no invisible substance filling space. Light was not a wave traveling through some material medium after all. And with that, every version of the pushing, carrying, limiting instinct collapses. There is no medium doing the work. There is no universal frame of rest that light is measured against. There is nothing filling space that light rides upon. We reached for a mechanism, for some physical thing responsible for the speed of light, and the universe took the whole category away from us. Whatever holds light to its one speed, it is not a substance, and it is not a push, and it is not the flowing of any medium at all. So we are left in a strange and slightly disorienting place. Every ordinary explanation has been removed, and it is exactly here, standing in the wreckage of the mechanism we were sure had to exist, that physics was finally forced into a completely different way of thinking about what light even is. Because if light is not a wave in some medium, and not a little bullet fired from a gun, then what on earth is it? The answer took nearly 2 centuries to arrive, and it changes everything about how the question of speed even makes sense. Part 7. Light is not a bullet. We have to give up a picture now, and it is a picture you have almost certainly been carrying without noticing. When most people imagine a photon, they imagine a tiny thing, a little bullet or a small marble, fired out of a lamp and flying across the room, a self-contained traveler crossing space with its own private speed. That image feels natural, and it is completely wrong. It matches nothing about how light actually behaves, and it will never explain why every photon in the universe moves at the same speed. To find the real answer, we have to trade the bullet for something far stranger and far more beautiful, and it begins with an idea that took physicists a very long time to trust: the idea of a field. A field is one of those words that sounds abstract, until you realize you already have a feel for it. A field is simply a quantity that has a value at every point in space and at every moment in time. The temperature in a room is a field. Every point in the room has some temperature, and together they make a smooth pattern that can change from moment to moment. The wind across a landscape is a field. Every point in the air above a valley has a wind speed and a direction. A field is just a rule that assigns something, a number or an arrow, to every location and every instant. That is all. Once you have that idea in hand, the next question is which fields the universe actually contains. And the answer, worked out over a couple of centuries, is that the universe is not fundamentally a collection of little hard particles rattling around in empty space. Underneath, it is made of fields, fields that fill all of space, that are present even where nothing seems to be happening, and that carry energy and the capacity for disturbance. The particles we talk about, electrons and photons and the rest, are not the primary things. They are ripples in these underlying fields, localized bundles of energy, in something that stretches quietly across the whole cosmos. For light, the field in question is the electromagnetic field, and of all the fields in nature, this is the one whose story we know best, because we were able to study it, measure it, and play with it long before anyone understood what it truly was. That story runs through the 1800s, and it starts with a self-taught experimenter working with wires and magnets in London. Step into that laboratory for a moment. Sometime in the 1830s, Michael Faraday, who had almost no formal mathematical training but possessed one of the finest physical intuitions anyone has ever had, has wound coils of copper wire around an iron ring. He has connected one coil to a battery through a switch, and another coil to a sensitive instrument that can detect the smallest electric current, and he notices something that should not, by the physics of his day, be possible. When he closes the switch, sending a steady current through the first coil, the needle on the second coil's detector twitches just for a moment, and then falls back to zero. When he opens the switch, the needle twitches again the other way and settles back. But while the current in the first coil flows steadily, unchanging, the second coil shows nothing at all. Steady current, no effect, only the change, the closing, and the opening. The moment of transition produces anything. This was the seed of everything. Faraday had discovered that a changing magnetic field creates an electric current in a nearby wire, but only while it is changing. A steady magnetic field, however strong, does nothing. Motion, change, variation, those were what mattered. The universe, he realized, cares not just about how things are, but about how they are changing. And Faraday, lacking the mathematics to write it in equations, described what he saw with a picture. He imagined invisible lines of force filling the space around magnets and around electric charges, threading through his coils, and he suspected that the real action was not in the wires at all, but in the space between them, where these lines of force lived. It was a radical thought. The interesting physics was happening in empty space, in the field. It is worth dwelling on how strange that idea was at the time, and how much it matters to our question. For centuries, physics had been about objects, things you could point to, and the forces between them were imagined as invisible tugs reaching across empty gaps. Faraday was proposing something almost heretical, that the empty gap was not empty at all, that the space around a magnet was filled with a real, physical something, a structure of force with a life of its own, and that this something, not the magnet and not the wire, was where the physics actually lived. He could not prove it with equations because he did not have them. He simply saw it in the behavior of his needles and his coils, with an intuition so sure that it turned out to be right about the most fundamental layer of reality. And here is why it matters for us tonight. If the real thing is the field that fills the space, and not the objects that stir it, then the speed at which disturbances travel through that field will be a property of the field itself, the same everywhere, indifferent to whatever happened to make the disturbance. Faraday did not live to see it spelled out, but his stubborn conviction that the action was in the empty space between things is the first quiet step toward understanding why a candle and a dying star hand their light the very same speed. The answer was never going to be found in the fire. Faraday was already looking in the right place, at the field that the fire merely disturbs. A generation later, in the 1860s, James Clerk Maxwell took Faraday's pictures and made them exact. He wrote down a set of equations describing how electric and magnetic fields behave and how each one can give rise to the other. A changing magnetic field creates an electric field. A changing electric field creates a magnetic field. And when Maxwell worked through the mathematics of what such intertwined, self-generating fields would do, he found something that must have stopped him cold. His equations allowed for a wave, a disturbance in which a changing electric field produces a changing magnetic field, which produces a changing electric field, on and on. A ripple that sustains itself and travels forward through empty space. And the equations did more than allow this wave. They told him how fast it would go. The speed came out of two numbers that had nothing, on their face, to do with light. One was a constant describing how strongly electric fields respond to electric charges, measured by careful experiments with charged objects sitting on laboratory benches. The other was a constant describing how strongly magnetic fields respond to electric currents, measured by experiments with current-carrying wires. Two numbers, pinned down separately, in experiments about static electricity and about magnets, with no reference to light whatsoever. Maxwell combined them the way his wave equation demanded, and out came a speed. And that speed matched, to within the precision anyone could measure at the time, the already known speed of light. That could not be a coincidence. Two constants describing electricity and magnetism, measured with no thought of light at all, combined to give exactly the speed of light. The only possible conclusion was that light itself was this wave, a self-sustaining ripple in the electromagnetic field, and that its speed was not an accident and not a separate fact, but was written directly into the structure of the field. Maxwell had unified electricity, magnetism, and light into a single thing, and in doing so, he had given us the first real answer to our question. Look at what that answer does. If the speed of light comes from the structure of the electromagnetic field, and the field is the same everywhere in the universe, then the speed must be the same everywhere. That is exactly what we see. If the speed comes from the field, and the field does not care what process produced any particular ripple, then the speed cannot depend on the source. That is exactly what we see. If the speed comes from the field, and the field is not a substance that can be pushed or dragged, then there is no way to give a photon a harder shove to make it faster. That too is exactly what we see. The source independence, the invariance across energies, the impossibility of speeding light up. All of it begins to make sense the moment you stop thinking of light as a bullet and start thinking of it as a ripple in a field whose very structure sets the speed. But a ripple in a field raises its own question. How does a wave hold itself together and move through empty space with no medium to carry it, at one exact speed and no other? And the answer to that is the most elegant part of the whole story. Part 8. The wave that carries itself. We are used to waves needing something to wave in. A wave on the ocean is water moving. A sound wave is air being squeezed and stretched. A wave running down a rope is the rope itself flexing. Take away the water, the air, the rope, and the wave is gone. So the strangest thing about a light wave, the thing Michelson and Morley's failure forced upon physics, is that it needs nothing to wave in at all. There is no medium, and that means a light wave has to do something no ordinary wave has to do. It has to carry itself. It has to be its own reason for continuing. And once you see how it manages that, you see why it can only move at one speed. Picture the wave as it travels. At every point along its path, there is an electric field and a magnetic field, standing at right angles to each other, and both at right angles to the direction the light is going. They are not sitting still. They are oscillating, rising and falling, and they are doing it in perfect step. Now follow the logic that keeps the whole thing alive. At this instant, the electric field is changing, falling from its peak back towards zero. And we learned from Faraday and Maxwell that a changing electric field creates a magnetic field. So the falling electric field gives rise to a magnetic field. But that magnetic field is changing too, because the whole pattern is oscillating. And a changing magnetic field, in turn, creates an electric field. So the changing magnetic field regenerates the electric field, which keeps changing, which sustains the magnetic field, which sustains the electric field, around and around, each one feeding the other, forever, as the wave rolls forward through empty space. This is the secret of how light travels with nothing to travel through. It is not being carried, it is carrying itself. At every point along its path, the changing of each field is exactly what is needed to regenerate the other, an instant later and a little further along. The wave is a self-sustaining loop, a pattern that keeps recreating the very thing that will let it continue. There is no medium, because the wave does not need one. The electric and magnetic fields are each other's medium, taking turns holding the wave up as it moves. And here is the part that answers our question. This self-sustaining loop only closes if the wave moves at exactly one speed. If it went any faster or any slower, the timing would fall out of step. The changing electric field would generate a magnetic field that no longer matched what the wave needed. The changing magnetic field would produce an electric field slightly out of place, and the delicate handoff between them, the thing that keeps the wave alive, would break down. The pattern would fall apart. Only at one specific speed does the whole exchange stay perfectly synchronized, each field regenerating the other in just the right amount at just the right moment. That speed is set by the two constants of the electromagnetic field, the same two numbers Maxwell combined, the strength with which a changing electric field makes a magnetic one, and the strength with which a changing magnetic field makes an electric one. Those strengths fix the pace at which the loop can sustain itself. The wave does not choose that speed. It is the only speed at which the wave can exist at all. There is a familiar thing that behaves in a similar way, and it helps to hold it in mind. Take a guitar string, or any stretched string, and pluck it. A wave travels along the string. Now notice something. You cannot change how fast that wave travels by plucking harder. Pluck gently and the wave is small. Pluck hard and the wave is large. But in both cases, the wave runs along the string at the same speed. That speed is not set by you or by how hard you struck the string. It is set by the string itself, by its tension, and by how heavy it is per unit of length. Change the string, and you change the speed. But once the string is what it is, the speed of any wave on it is fixed, and you can make waves of any size, any frequency, any shape, and they all travel at that same speed. The string decides. The electromagnetic field works in a way that echoes this. Its two constants play a role, something like the string's tension and weight. They set the speed at which any ripple in the field can travel. And so, exactly as with the string, you cannot make a light wave go faster by pouring more energy into it. You can make it a taller wave, a higher frequency wave, a shorter wavelength wave, a more energetic wave. You cannot make it a faster wave. The speed belongs to the field, and the field permits one speed and one speed only. Suddenly, everything we found earlier fits. The gamma-ray photon and the radio photon travel at the same speed because they are both ripples in the same field, and the field allows only one speed for its ripples, no matter how much energy each one carries. But I have to be honest about the limits of the string picture, because the difference is important, and it points where we are going next. A string is a real, physical object. It has mass. It is made of atoms. It hangs in space, and has a place where it sits still. The electromagnetic field is nothing like that. It is not made of tiny particles vibrating. It is not a fabric stretched across the sky. It has no substance you could weigh, no preferred direction, no state of rest. The field is not a thing sitting inside space, waiting to be plucked. As far as our physics can tell, the field is one of the ground-level features of reality itself, present at every point in space, whether or not anything is happening there. When nothing disturbs it, it rests quietly at its lowest state, and we call that region empty. When something disturbs it, a ripple forms and travels, and we call that ripple light. So the string can only take us so far. A wave on a string still needs the string. A wave in the electromagnetic field needs nothing beneath it, because the field is already the bottom. And that means the speed of light is not resting on some more basic mechanical fact about a medium. It is resting on the structure of the field itself, and the field is as far down as this part of the story goes, which is a remarkable place to have arrived. We started with a candle and a collapsing star, and we have found that the speed of their light is written into a field that fills all of space and needs nothing to hold it up. It feels like an answer, and it is, but only half of one, because there is a question the field, by itself, cannot answer, and noticing what it leaves out is what forces us down to the very bottom of this whole mystery. Part 9. What we have so far. Let me stop here at what feels like the middle of the climb and gather everything we are holding, because we have collected more than it might seem, and the next step is going to ask us to leave familiar ground entirely. It helps to have the pieces stacked cleanly before we go. We began with a plain observation. Every photon in the universe, from a candle flame to a gamma-ray burst, moves through empty space at exactly the same speed. From there we started removing the ordinary explanations, one after another. We found that the source does not set the speed, because sources that share nothing produce light of identical speed. We found that the energy of the light does not set the speed, because the sky itself has raced photons 1,000,000 times apart in energy across 7 billion years, and watched them arrive together. We found that light does not build up to its speed, because a photon is never at rest, never accelerating, but already at full speed the instant it exists. We saw that even the famous number is a human convention, a matter of units, hiding the real fact underneath it, which is not the size of the speed, but its sameness. We reached for a mechanism, some substance, or push, holding light to its pace, and the most careful experiment of its age took the whole idea of a medium away from us. And then, finally, we found the first real answer. Light is not a bullet. It is a ripple in the electromagnetic field, a wave that carries itself. and the structure of that field permits exactly one speed for its ripples, no matter what makes them. That is genuine progress, and it explains a great deal. It explains why the speed does not depend on the source, because the speed belongs to the field, not to whatever stirred it. It explains why more energy does not mean more speed, because energy makes a taller or faster oscillating wave, not a faster traveling one. It explains why the speed is the same everywhere, because the field is the same everywhere. The field answer is real, and it is beautiful, and we should not undersell it. There is one more layer worth adding before we go on, because it sharpens the picture. When Maxwell wrote down his wave, he described light as a smooth, continuous ripple. But when physicists in the early 20th century looked closely at how light actually behaves when it meets matter, they found that it does not always arrive smoothly. Sometimes it comes in discrete little packets, each carrying a specific amount of energy. Those packets are what we call photons. The resolution, which came with quantum mechanics, is that the electromagnetic field is quantized. Its ripples come in indivisible units. A single photon is one quantum of vibration in the field, the smallest possible disturbance the field can carry at a given frequency. A higher frequency photon carries more energy, a lower frequency one carries less. But every photon, without exception, is a ripple in the same underlying field. And so every photon travels at the same speed, for the same reason, because the field allows that one speed for its ripples and no other. The quantum picture does not overturn the field answer. It sharpens it. Whether you think of light as a smooth wave or as a stream of individual quanta, it is the field that sets the speed. So you might think we are done. We have an answer that seems to cover everything. And for a while, historically, that is roughly where things stood. But there is a question the field answer cannot touch, and once you notice it, you cannot unnotice it, and it sends the whole investigation down another level. Here is the gap. The field explains why every photon has the same speed. It does not explain why every observer measures that same speed. Those are not the same claim, and the difference between them is enormous. Think about it this way. Suppose the electromagnetic field fills space and sets one speed for its ripples. Fine. But if I start chasing a photon, running after it as fast as I can, shouldn't I measure it moving a little slower relative to me, the way a car I chase on the highway appears to slow down as I speed up? The field answer, on its own, does not obviously forbid that. It tells me the speed of the ripple through the field. It does not tell me why my own motion, my running, my chasing, should make no difference to what I measure. And yet, as the collapse of the ether already hinted, and as we will see proven in a moment, my motion makes no difference at all. Every observer, no matter how they move, measures light at the same speed. Chase it, flee from it, race toward it head-on, and the number does not change. The field by itself does not explain that. There is something more going on, something that does not live in the electromagnetic field at all, but in the stage that the field and everything else is set upon. There is a reason the speed of light shows up not only in the equations of electricity and magnetism, but also in equations about moving clocks, about shrinking rulers, about energy and mass, about cause and effect, equations that have nothing to do with light. That reason is the lowest layer of this whole story, and it is where our question is finally going to be answered, not with a mechanism, but with the shape of space and time themselves. To get there, we have to do what Einstein did. We have to take the strangeness of light's constant speed, not as a puzzle to be explained away, but as a clue, and follow it into a place where space and time stop being the fixed, reliable things we imagined them to be. Part 10. The speed everyone agrees on. For most of human history, space and time were thought of as the fixed stage on which everything else happened. Space was the empty container that things sat in. Time was the steady ticking that carried events along. Everyone shared the same space and the same time. If two things happened at once for you, they happened at once for everyone. If two objects were a certain distance apart, that distance was simply a fact, the same for any observer. Space and time were absolute, universal, the unquestioned backdrop of reality. And then, in the year 1905, a young patent clerk named Albert Einstein took that backdrop apart, not by inventing something wild, but by taking two known things seriously at the same time, and refusing to look away from what followed. The first thing was an old and reasonable principle. The laws of physics should look the same to every observer moving steadily, at constant velocity. There is no special, privileged state of motion. Someone gliding smoothly through space sees the same physics as someone standing still. The second thing was Maxwell's discovery, the one we just walked through. The equations of electricity and magnetism contain a specific speed for electromagnetic waves, the speed of light, built right into the constants of the field. Einstein simply asked, what happens if both of these are true at once? If the laws of physics look the same to every steadily moving observer, and if the speed of light is part of those laws, then the speed of light must look the same to every steadily moving observer. Every one of them, no matter how they are moving, must measure light at the same speed. That sounds harmless until you follow it. Suppose you are standing still, and a photon flies past you, and you measure its speed. Now suppose someone races along in the same direction as the photon, at half its speed, and measures the same photon. Common sense says they should find it moving at half the speed you did, because they are chasing it. But they do not. They measure the full speed, exactly what you measured. And if a third person rushes toward the photon head-on, meeting it, they also measure the full speed, not faster. No matter how you move, the photon always comes at you at the same speed. This is not how anything else behaves. If you drive down a highway at 60 and another car goes the same way at 40, that car crawls past you at 20. If it comes toward you at 40, it closes on you at 100. Speeds add and subtract in the ordinary way. But when the moving thing is light, that ordinary arithmetic simply breaks. Chase it or flee it as fast as you like, and light meets you at the same speed every time. Einstein did not invent this behavior. The experiments had already been hinting at it, the failure of Michelson and Morley among them. What Einstein did was take it seriously and refuse to patch it over, and then ask what the world must be like for it to be true. And the answer is that space and time cannot be what we thought. If everyone measures the same speed for light, no matter how they move, then something has to give, because speed is distance divided by time. If different observers all get the same speed while moving differently, then they cannot all agree about distances and about times. Their measurements of length and duration must differ, in exactly the way needed to keep the speed of light the same for all of them. This is where the famous strangeness of relativity comes from, and it is worth saying plainly that it is not a trick or an illusion. When you move relative to me, I see your clock running slow, not because your clock is broken, but because time itself passes differently for you, from my point of view. I see lengths along your direction of motion contract, not because your rulers have physically crushed, but because distance itself is different for you. These effects are real, and they have been measured over and over, with fast particles in accelerators, with atomic clocks flown around the world on airplanes, with the satellites overhead whose timekeeping has to be corrected for exactly these effects, or they would fail. Space and time stretch and shrink in a coordinated way, and the whole point of the coordination is to keep one thing fixed, the speed of light. It is the quantity that does not bend when everything else does. It is invariant, the same from every point of view, the one solid thing in a world where distance and duration have become negotiable. Take a breath here, because this is one of those places where physics asks you to give up something you did not know you were holding. You have always assumed, as everyone does, that time is time, the same for everyone. A single current carrying all of us along at one steady rate. You have assumed that a meter is a meter, that if two people measure the same object carefully, they must get the same length. Relativity says no. It says that your now and my now are not the same now if we are moving differently, that your seconds and mine can run at different rates, that a ruler's length depends on who is measuring it and how they move. And this is not philosophy or wordplay. It has been measured again and again with a precision that leaves no room to wriggle out. Atomic clocks flown around the world on ordinary airliners came back disagreeing with clocks left on the ground by exactly the amount predicted. Particles that should decay in a fixed tiny time survive far longer when they move fast, their internal clocks visibly slowed. The satellites overhead would fail within a day if their clocks were not corrected for these effects. Time really does stretch. Distance really does shrink. The solid, universal stage we thought we were standing on turns out to flex and give, bending itself into whatever shape is needed. And through all of that bending, one thing holds perfectly still and refuses to change for anyone: the speed of light. Everything you thought was absolute turns out to be negotiable, and the one thing you might have guessed was arbitrary, the speed of a beam of light, turns out to be the bedrock the whole of reality is arranged around. A few years later, in 1908, one of Einstein's former teachers, Hermann Minkowski, found the way of seeing this that we still use. He pointed out that space and time, in relativity, are not really separate at all. They are woven together into a single four-dimensional structure, space-time, and every event, everything that happens anywhere at any moment, is a single point in it. And in the geometry of space-time, the speed of light plays a very particular role. It is the conversion factor between space and time, the exchange rate that tells you how much distance corresponds to how much duration. That is why the speed of light turns up in equations that have nothing to do with light, in the relation between energy and mass, in the formulas for time dilation and length contraction. It is not that photons keep sneaking into those equations. It is that the speed of light is a feature of space-time itself, and anything living in space-time meets it. Let me make this real, because it is easy to let the words slide past. Imagine two observers, and call them Alice and Bob. They pass each other in deep space, far from everything, Alice drifting freely, and Bob coasting past her at a large fraction of the speed of light. Both are careful physicists with identical, high-precision instruments, and they have agreed to do one thing. As a single photon streaks past both of them, each will measure its speed. The photon arrives. Alice measures it with her clocks and her rulers and gets a number. Bob measures it with his clocks and his rulers and gets a number. And their numbers are the same, not close, exactly the same. Now here is where it turns strange. If Alice looks over at Bob's clock, she sees it ticking slower than hers. If Bob looks at Alice's clock, he sees hers ticking slower than his. If Alice looks at Bob's ship, she sees it shortened along its direction of motion. If Bob looks at Alice's, he sees hers shortened. Each of them, measuring that photon, used clocks ticking at different rates and rulers of different lengths. Their seconds were not the same length. Their meters were not the same length. And yet, when each divided the distance the light travelled by the time it took, they landed on the identical speed. The differences in their clocks and their rulers were calibrated by the geometry of space-time to cancel out perfectly and deliver the same speed of light to both. That is what invariance means. Not that everyone agrees on everything, but that in the middle of all this disagreement about time and distance, there is exactly one thing everyone agrees on, and it is the speed of light. So notice what has happened to our question. We asked what fixes the speed of light, and the field gave us half an answer. Now the other half is coming into view, and it is stranger and more basic than the first. The speed of light is not fundamentally a fact about light at all. It is a fact about space and time. It is the fixed point around which the whole structure of space-time is built, the one invariant in a world where everything else flexes. The field told us why every photon has the same speed. Space-time is telling us why every observer measures that speed the same, and why this one number is woven through all of physics. But we still have not reached the very bottom, because there is one more question sitting underneath even this, and it is the one that finally explains why light, of all the things in the universe, is locked to this speed and can never, ever be at rest. To answer it, we have to talk about mass. Part 11. The reason nothing else can keep up. We have arrived at the question underneath all the others. Space-time has an invariant speed built into its geometry, one special speed that everyone agrees on. But that raises a sharp and beautiful question. Why does light travel at that speed, while everything else, you, the Earth, a rocket, a fast particle in a laboratory, travels below it and can never reach it? What is it about light that locks it to the one speed? And what is it about everything else that forbids that same speed forever? The answer is a single word, and it changes how you see not just light, but your own body. The word is mass. Every object in the universe has a property called rest mass, the mass it has when it is sitting still. A baseball has a rest mass of about 1/7 of a kilogram. An electron has a rest mass fantastically smaller than that, but crucially, and this is the whole point, not zero. And any object with a rest mass that is not zero, however tiny, has a special feature in the geometry of space-time. It has a rest frame. There is a way of setting up your point of view in which that object is not moving. You could, at least in principle, run alongside it, match its velocity exactly, and watch it sit still beside you. A baseball can rest on a bench. An electron can be trapped and held. Anything with mass can, from some point of view, be at rest. Now here is where the geometry lays down its law. An object with mass traces a path through space-time, moment by moment, that physicists call its world line. And the geometry insists that this world line must always stay inside a certain region, shaped like a cone, defined by the speed of light. Picture standing at a single event, a single point in space, at a single moment. From that event, light spreads outward in every direction, and as time goes forward, that expanding sphere of light traces out a cone in space-time, the light cone of that event. Anything moving slower than light stays inside the cone. Anything with mass is required to stay inside the cone. Always, no exceptions. To leave the cone would mean traveling faster than light, and the geometry forbids it, because it would take an infinite amount of energy. Let me show you why the energy runs to infinity. Because it is not a hand wave, it is the very reason massive things are trapped below the speed of light. As you push a massive object faster and faster, its energy grows, which is familiar. But near the speed of light, the energy does not grow in the gentle way ordinary experience suggests. It grows without limit. The closer the object creeps to the invariant speed, the more energy it takes to gain even a sliver more velocity. To nudge something already near the speed of light, a hair closer, requires enormous energy. To nudge it closer still requires vastly more. And to actually reach the speed of light would require not a great deal of energy, not an unimaginable amount, but literally an infinite amount. The universe does not contain infinite energy, and so no object with mass can ever reach the invariant speed. It can approach it, closer and closer, forever, and never arrive. This is not a limit of our engineering. It is written into the geometry of space-time, and it has been confirmed every single day in particle accelerators, where particles are pushed to within a whisker of the speed of light, and their energies climb to thousands of times their rest energy, and still they never quite touch the speed itself. That is one side of the story. Massive things are locked below the speed of light because they have a rest frame, a state of stillness, and the geometry keeps their world lines inside the cone. Now flip it over and ask about something with no rest mass at all. This is where light lives. If an object has zero rest mass, The very same equations that forbid massive things from reaching the invariant speed do something completely different. They do not forbid a massless object from moving at the invariant speed. They require it. A massless object cannot move at any speed less than the invariant speed. It cannot sit still. It cannot go slowly. The only speed available to it, the only speed the mathematics permits, is the one invariant speed of light. The relationship between energy, momentum, and mass in relativity works out so that a massless thing carrying any energy at all must be moving at exactly that speed. If a photon had zero energy, it would not exist. It would be nothing. The moment it exists, it has energy, and the only way for a massless thing with energy to satisfy the equations is to be moving at the full speed exactly. Do you see what this does to the whole idea of light accelerating? A photon does not need to speed up to the invariant speed, because there is no slower state for it to speed up from. It has no rest frame. There is no point of view from which it is still, no version of it waiting at zero to be pushed. The instant a massless ripple of the electromagnetic field comes into being, it is already moving at the full speed, because that is the only way for a massless thing to exist at all. Remember, all the way back, the phrase we could not yet explain, that there is no zero state to accelerate away from. Now it has teeth. A photon has no zero state because it has no mass, and a thing with no mass has no stillness anywhere in the universe. Its existence and its motion at the speed of light are one and the same fact. Let me bring this down out of the abstract, because there is a piece of physical proof falling through the sky above you as you listen. High in the atmosphere, cosmic rays from space are constantly slamming into the upper air, and among the debris they create are particles called muons. A muon is like a heavy cousin of the electron, and it is unstable. Left to itself, a muon lives only about 2/millionths of a second before it decays into other particles. Now do the arithmetic that troubled physicists for a while. Muons are created roughly 15 kilometers up, even moving at nearly the speed of light. A particle that lives only 2/millionths of a second should travel only a few hundred meters before decaying. It should never reach the ground. And yet muons made in the upper atmosphere are detected at the surface of the Earth in huge numbers, every second, all the time. Ride down with one of them, and you can feel how it happens. From our point of view on the ground, the muon is moving so close to the invariant speed that its internal clock is dilated, stretched out enormously. Its 2/millionths of a second, from our frame, becomes long enough to cross the whole distance, and it reaches us before it decays. From the muon's own point of view, its clock runs perfectly normally, and it truly lives only 2/millionths of a second. But from that point of view, the atmosphere is rushing past and is contracted. The 15 kilometers squeezed down to a short hop it can easily cross in the time it has. Two different stories, our stretched time and its shrunk distance, and both give the same answer. The muon arrives. It arrives every time, in exactly the numbers relativity predicts. The particle reaches the ground only because the invariant speed of light reshapes time and space around it, and the proof is raining down on your roof at this very moment. And that same invariant speed, the one that lets the muon reach the ground, is the one you rely on every time you check a map on your phone. The satellites of the positioning system carry atomic clocks, and because those satellites move quickly and sit high in Earth's gravity, their clocks tick at a slightly different rate than clocks on the ground, exactly as relativity says they must. If that difference were ignored, the position your phone reports would drift off by about 10 kilometers every single day. It does not drift because the correction is built in, and the correction works because the invariant speed of light is real and behaves precisely as the geometry of space-time demands. The strangeness we have been chasing all night is not exotic. It is in your pocket, keeping you from getting lost. There is a larger meaning to this invariant speed that is worth drawing out before we finish, because it is not only a limit on how fast things can go, it is the boundary of cause and effect itself. Go back to that cone in space-time, the light cone spreading out from every event. Everything inside the cone, in the direction of the future, is a place the event can reach, a place, a signal, or an influence traveling at or below the speed of light could arrive in time to affect. Everything outside the cone is unreachable, cut off, causally disconnected, because to get there you would have to travel faster than light, and nothing can. The invariant speed, in other words, draws the line between what the present can influence and what it cannot. It sets how much of the future is open to you from where you stand, and how much of the past could ever have reached you. Every event in the universe carries its own light cone, and every one of those cones has the same shape, because the invariant speed is the same everywhere. This is why the speed of light turns up as the ultimate speed limit for everything, not just for light. It is not that light is special and everything else politely stays below it. It is that the speed marks the edge of causality, the fastest that any influence, any signal, any cause reaching toward any effect can move through space-time. Push beyond it, and you are not just going fast, you are stepping outside the order of cause and effect, into a place where effects could come before their causes, and the whole logic of before and after falls apart. The universe does not allow it, and so the same number that fixes the speed of a candle's light also fixes the pace at which the universe is allowed to connect one moment to the next. That is a heavier thing than a speed. It is the rate at which reality itself unfolds, and light rides it, not because light is important, but because light, being massless, has no choice but to travel at the exact speed the universe uses to stitch cause to effect. So now we can almost say the whole thing plainly. Light travels at the invariant speed and never accelerates to it, because it is massless, and a massless thing has no rest frame, no stillness, no zero state, and is required by the geometry of space-time to exist only at that one speed. The source cannot change it, because speed is not the source's to give. It belongs to the field and to space-time. The energy cannot change it, because energy is not what sets the speed of a massless thing. And there is no acceleration, because there was never anything slower to leave behind. We are one step from the full answer, but before we take it, honesty requires that we deal with the one thing that seems, on its face, to contradict everything we have said, because you have surely noticed it already. Light does slow down. Put it in glass, or water, or a diamond, and it visibly, measurably, travels slower. If the speed of light is so absolute, so woven into the fabric of reality, how can a simple piece of glass slow it down? That loose thread has to be pulled, and pulling it, strangely, ties the whole thing tighter. Part 12. The glass that seems to break the rule. Here is the objection, and it is a good one. We have spent this whole time insisting that light in empty space moves at one invariant speed, the same for every photon, woven into space-time itself, impossible to change. And then you pick up a glass of water, or look through a window, or admire a diamond, and the light slows down. Not by a little. Light in water travels at about 3/4 of its vacuum speed. In ordinary glass, about 2/3. In diamond, less than half. If the speed of light is truly stitched into the fabric of the universe, how can a chunk of ordinary matter slow it so dramatically? Either the invariant speed is not so invariant, or something subtle is going on that we have not yet accounted for. It is the second one, and the resolution is one of the most quietly beautiful pieces of physics there is, because the exception turns out to confirm the rule rather than break it. The key is that a piece of glass is not empty. Empty space contains only the electromagnetic field, resting quietly at its lowest state. A piece of glass contains that same field, but it also contains an enormous, densely packed lattice of atoms, trillions upon trillions of them in every cubic centimeter, and every one of those atoms has electrons that respond to light. When a light wave enters the glass, it does not stop being a wave in the electromagnetic field, and between the atoms, in the tiny gaps of genuine vacuum, it still travels at exactly the invariant speed. But it cannot cross the glass without constantly interacting with all those atoms in the way. And that interaction is what slows the overall wave. Here is what actually happens, and it is worth going slowly. As the light wave passes an atom, its oscillating electric field pushes and pulls on the atom's electrons, setting them wiggling. But a wiggling electron is an accelerating electric charge, and an accelerating charge produces its own electromagnetic wave. So each atom, jostled by the incoming light, radiates a small new wave of its own. Now the total light inside the glass is not just the original wave. It is the original wave plus the sum of all these tiny secondary waves, re-radiated by every atom the light has passed. And when you add all of them together, the original wave plus the countless little contributions from the atoms, the combined result is a wave whose crests and troughs advance through the bulk of the glass more slowly than the original wave alone would have. The atoms are not slowing individual photons by dragging on them like friction. They are contributing their own waves. And the sum of everything, the grand total of the original plus all the re-radiations, is a pattern that moves forward more slowly. Physicists call this the phase velocity of light in the medium, and it is a real, measurable thing. It is genuinely what we mean when we say light travels slower in glass. But it is a collective effect, a property of the whole wave interacting with the whole material, not a change in the fundamental speed of light itself. Underneath, between the atoms, the invariant speed is doing exactly what it always does. There is a rougher, more intuitive way to hold this picture, though it is not quite literally accurate. Imagine the photon traveling through the glass and, along the way, being absorbed by an atom, and then, a tiny moment later, re-emitted, absorbed again by the next atom, re-emitted again, over and over, all the way through. Between those little encounters, the photon moves at the full invariant speed, but each encounter introduces a tiny delay, and over the whole thickness of the glass, all those tiny delays add up into a noticeable lag, so that the light emerges later than it would have if the glass were not there. The photon was never actually moving slowly. It was moving at full speed between interactions, and being repeatedly held up for an instant along the way. What we measure as the speed of light in glass is really an average over that whole intricate dance between the field and the atoms. Why do different materials slow light by different amounts? It comes down to how densely their atoms are packed, and how strongly their electrons respond. Diamond is one of the most extreme everyday examples. Its carbon atoms locked in an extraordinarily rigid, tightly packed crystal, their electrons responding powerfully to light across a wide range of colors. Every atom contributes a strong re-radiated wave, and the accumulated delay through even a thin slice of diamond is large, which is why light crawls through it at well under half its vacuum speed. Water, a loose liquid, slows light much less. Glass sits in between, and there is a further subtlety that produces one of the most familiar sights in nature. Different colors of light are slowed by slightly different amounts in the same material, because the electrons respond a little differently to different frequencies. In ordinary glass, blue light is slowed a touch more than red. This frequency-dependent slowing is called dispersion, and it is exactly why a glass prism spreads white light into a rainbow, each color bending by a slightly different amount because each effectively travels at a slightly different speed inside the glass. The rainbow on your wall from a cut glass window is the collective wave, sorting itself by color. The invariant speed underneath is untouched. Physicists have pushed this to remarkable extremes. In certain laboratories, Using ultra-cold clouds of atoms prepared in delicate quantum states, they have slowed the effective speed of a light pulse down to the pace of a bicycle, and in some experiments even brought it briefly to a complete stop, holding the light still for a fraction of a second before letting it continue on its way. It sounds like a violation of everything we have said, light standing still in a laboratory. But at no moment during any of these experiments is any individual photon moving at anything other than the invariant speed between the atoms. The apparent slowing and even the apparent stopping is a collective effect of the wave's interaction with the atomic cloud, a matter of the combined pattern being held up, not of the fundamental propagation of light through vacuum being changed. The invariant speed is intact the entire time. It is worth savoring how completely this turns the objection around. You began by pointing at a glass of water, as if it were a crack in the whole story, a place where the invariant speed plainly fails. And when you look closely, the glass of water turns out to be one of the best demonstrations that the invariant speed is exactly as absolute as we said. The light slows, yes, but only as a grand sum of countless photons, each moving at full speed between the atoms, held up for tiny instants by their encounters with matter, emerging late, but never once traveling slow. Take the matter away, and the delay vanishes, and the light snaps back to the one speed it always had. The medium can borrow the light, pass it from atom to atom, hold it up, even seem to freeze it in place, but it can never change the speed at which light truly moves, because that speed was never the glass's to set in the first place, any more than it was the candle's. Everything that touches light, the fire that makes it, the energy it carries, the glass it crosses, the observer who measures it, gets to shape some part of its story. None of them gets to touch its speed. That belongs to something more basic than any of them, and the glass, for all its apparent slowing, leaves it exactly as untouched as the empty space between the stars. So the loose thread, pulled, does not unravel the sweater, it tightens it. Light really does slow in glass, and water, and diamond, and it slows as a wave interacting with matter, never as a photon that is somehow tired or dragged. The moment you take the atoms away, the moment you give the light nothing but empty space, it moves at the one invariant speed, the speed woven into space-time, the speed no source and no energy and no observer can change, which means we have now cleared away the last objection. Every strand of the mystery is lying open in front of us. We know the source does not set the speed. We know energy does not. We know there is no medium, no ether, no push. We know light is a self-sustaining ripple in the electromagnetic field, and that the field permits one speed. We know that speed is invariant for every observer because it is built into the geometry of space-time, and we know that light is locked to it and can never be at rest because it is massless. It is time, at last, to put it all together and answer the question we started with, the question that has been waiting patiently since the first candle flame. Why doesn't light ever accelerate? Part 13. Why light never had to speed up. We are finally in a position to answer it, cleanly and completely. And the answer is not that light does something special. The answer is that the universe is built in such a way that light cannot do anything else. Let me say it plainly, and then let me show you how every piece we have gathered clicks into it. Light does not accelerate because it has no rest state to accelerate from. That is the whole answer, and everything we have learned tonight is packed inside it. A photon is a massless ripple in the electromagnetic field, and it lives in a space-time whose geometry allows a massless thing to exist only at one speed, the invariant speed woven into the structure of space and time. Because the photon has no mass, it has no rest frame, no point of view from which it sits still, no stillness anywhere in the universe. And a thing with no stillness cannot accelerate, because acceleration means going from slower to faster, from a smaller speed to a larger one. And light has no smaller speed to leave behind. The instant a photon exists, it exists at the full speed of light, not because something pushed it there in record time, but because there was never anywhere else for it to be. Acceleration is something only a thing with a rest state can do. Light has none. Light does not refuse to accelerate. It was never in a position to. Now watch every earlier piece fall into place around that answer. Remember how we found that the source of a photon controls its energy, its frequency, its wavelength, its direction, its polarization, everything but its speed. We can finally say why. Speed is not the source's to give. The source imprints all those other properties because they are features of the particular ripple it creates. But speed is not a feature of the ripple. It is a feature of the field the ripple lives in, and of the space-time the field lives in, and no source can reach that far down. The fire makes the light, but the field and the geometry of the universe decide how fast it goes, and they decide the same way every time, for the candle and the collapsing star alike. Remember how we found that a photon, carrying 1,000,000 times more energy than another, still crosses 7 billion years of space in perfect step with it. We can say why now too. Energy sets what kind of ripple the photon is, how tightly it oscillates, where it sits on the spectrum. But energy does not touch the speed, because the speed belongs to the massless nature of the thing and to the geometry it moves through, not to how much energy it happens to carry. The gamma ray and the radio wave are both massless ripples in the same field, in the same space-time, and so they move at the same speed, and no amount of energy will ever change that. And remember the phrase from the very beginning, the one that sounded like a bare curiosity when we first said it. There are no fast photons. There are no slow photons. There are only photons, moving. When we first said those words, they were just an observation, a strange fact standing on its own. Now they are an explanation. There are no fast or slow photons because a photon is massless, and a massless thing has exactly one speed available to it, the invariant speed of space-time, with no faster and no slower anywhere in the range. The sentence has not changed. What has changed is that we now know why it has to be true. It could not have been otherwise, not in this universe, not with this geometry. There is one last turn of the screw, and it is the most fundamental thing of all. So let it land slowly. We have been calling this the speed of light all night, as everyone does. But it is not really the speed of light. It is the speed that any massless thing must travel. Light happens to be the most familiar example, because photons are massless, and we meet them everywhere, in every sunrise and every screen. But if there are other massless things in the universe, and physics expects there are, they travel at exactly the same speed, for exactly the same reason. The invariant speed is a property of space-time, not a property of light. It would exist even in a universe that contained no light at all. It is the maximum speed for anything, the speed at which cause and effect propagate, the rate at which any influence can cross from one event to another. Physicists sometimes call it the speed of causality, and that name is closer to the truth than the one we usually use. We named the number after light because light was the first massless messenger we noticed riding it. But the road was always there. Light simply travels on it because it has no mass to hold it back. Think about what that means for the light around you right now. The glow of your lamp, the faint warmth on your skin, the light that left a star thousands of years ago and only tonight reached your window. All of it is riding the speed limit of reality itself, the fixed exchange rate between space and time that the universe was built with. Not because anything is pushing that light, not because it burns some hidden fuel, not because empty space carries it along, but because light is a massless ripple in a field that fills all of space, in a universe whose geometry leaves it no other way to be. The speed of light is the speed of the universe, the number that says how much space answers to how much time, and light rides it for the simplest reason imaginable. It has no weight to keep it from the top. So when you ask why light never accelerates, you are really asking why a thing with no stillness never has to find its speed. And the answer is that it was born with it, the only speed it could ever have. Every photon that has ever existed, from the first light that streamed out of the early universe when it cooled enough to become clear, to the light leaving your candle tonight, has been moving at exactly the same speed, from its first instant, for exactly the same reason. It was massless. It was in this space-time. It had no other option. There was never a slower photon that sped up. There was never a moment of acceleration. There was only light, coming into being, already at the speed the universe allows, and holding there, unchanging, until something absorbs it, and its brief life ends. And that, in the end, is the quiet elegance underneath the whole mystery. We started by asking what makes light so fast, and how it reaches its enormous speed, and we found that the question had it backwards from the start. Light was never slow. Light never accelerated. Light never had to reach anything. It simply is the kind of thing that exists at the speed of causality, the way you are the kind of thing that exists in time. The strangeness we felt at the beginning, watching a candle and a collapsing star pour out light at the identical speed, was not a sign that something exotic was happening. It was a sign that we were finally looking at the plainest fact in all of physics, the one speed the universe is built around, showing itself in the most ordinary light in the room. There are no fast photons. There are no slow photons. There are only photons, moving, at the speed of the universe, because they were never able to do anything else.